Hi there, Leith Anderson from the Indy Putting Lab upstairs at Correct to Compete. We're at the Indiana Golf Association annual show, the annual meeting that all the pros from Indianapolis, Indiana get together. And Sean Toulon, who's Senior Vice President from Callaway, came out just for this show because Callaway is the big sponsor.
Right.
Now, Sean runs the putter business for Callaway. And you might know his individual line, which was Toulon Designs, that he sold to Callaway before they bought the company,
Right.
brought you over, and so now you run the putter business for him. So,
Correct.
So we've been talking about what's going on with putters these days, and our story has been technology is really going to be dominant. And so technology was early on was kind of focused on insert design,
Right.
milling patterns.
Mhm.
So why don't you just describe a little bit of
Yeah.
what you did with that in the
Yep.
first stage?
Okay, well, I would agree with everything that you just said, Leith. So we have spent a lot of time, energy, effort, resources, money on trying to understand what we can do to get a golf ball to roll forward faster, right? There's always going to be a degree of skid. We'd like to make that skid as little as possible, but definitely when you see golf balls rolling into the hole, they're going this way, not
You
backspin,
wanted
right?
to dive in.
So as fast as you can, right? So there's a bunch of different technologies that you can use, but the one that we've really used on these inserts called White Hot Micro Hinge at Odyssey is really based on this dynamic groove system. So it's actually a groove, the micro hinges that actually are buried inside this urethane white insert material that actually gives it a little bit of give. And what you'll see is the insert itself, or the hinges, will actually come out, grab a hold of the golf ball, lift it a little bit to give you a little bit of launch angle, which you need. But more importantly, it comes off with forward roll.
Yeah.
And that's been super effective for us.
So that's in the Odyssey line.
That's
and then,
correct.
Describe what you did with the two-line line.
So on the Toulon, which is just now at the really high end, all milled putters for Odyssey, we did something really different because we wanted a line of our putters milled to give you a little bit more feedback, a little bit crisper response, if you will. So the fully milled face, but we also wanted it versus other milled putters to be a little quieter. That makes it feel a little softer to a golfer, but more importantly, to get more forward roll than a typical milled putter. So you can see this groove system that we have in here, kind of crosshatch. We call it deep diamond mill. So some of it is designed to really to channel shock or the frequency of or the vibration from impact away, so it kind of dissipates, much like water would do on a car tire. Because if you hear less sound, it's quieter, it will feel softer. So people have loved this, doing phenomenal on tour. But more importantly, there's a little groove in the middle of each of those diamonds, Leith, that does the same thing, creates friction, gives the ball a little bit of lift, and gives it a lot more forward roll than most milled putters.
So that's really pretty outstanding. So
That's
how
pretty
long
cool.
That technology, you said you had that when you were with Toulon, and
Right.
you just brought that with you.
Correct.
So it's been out for 3 years? or
Yeah,
so?
about 3 years.
About 3 years.
Yeah.
So now, describe for everybody what's going on performance on tour, because you guys are, you've been doing your research and realizing that it's not always getting better out there.
No, it hasn't. So, we spend now Odyssey, dominant number one putter in golf. We like to tell people that because one, it's true, which is handy. But secondly, we're really proud of it. That means we sell more, we have more in play on the tours around the world. We have more wins than almost all other putter companies combined. So
your R&D can be a little bit.
well, we have some resources that a lot of other companies don't, so we don't take that lightly. But when we really dug into the things that we thought were the most important, which is alignment, golfers typically don't align very well. After all this time, energy, effort, money, resource that we put into that, guess what? They're still not very good at aligning. So
that's what guys like us can help them.
well, so that's probably as much technique as anything, right? And we've improved forward roll, but a lot of companies have done a nice job there. But still, when we really dug into the numbers, Leith, what we're seeing is even the best putters in the world that play on the PGA Tour or European Tour aren't necessarily getting better.
Okay, and that brings
It's a
us
problem.
That brings us to the next question,
right.
Which is, okay, we've got the face technology solved. What are we going to do next?
Yeah.
And that's where the shaft story comes into play.
I'm going to correct you one thing. I would say we never have anything totally solved. Because if we did, what the heck would I do next year, right?
Oh, well, make a new company and just
But we can always get better, and we're always learning, right? But I think something like this happens because we're just a bunch of pretty curious people that happen to love golf and have spent our life doing
Well,
this.
we've been seeing this is one of the things we've been saying is that the shaft story
Yeah.
is really going to get to be important for putters, just like it is for the rest of the full swing clubs. And
Yeah.
so you've got the stability shaft out there, you've got Acro with flexes,
Right.
you've got Bryson DeChambeau playing one from LA Golf.
Right.
You know, I mean, there's all kinds of stories. So let's go into the shaft technology that you guys have.
It's interesting on this one, Leith, because we didn't start out with the mindset as we have to reinvent the shaft. What we looked at is golfers aren't getting better. So why is that? I mean, something else has got to be going on, right? So here's what we saw, that putter heads over time have gotten dramatically heavier. So back in
It
the
was a trend.
70s and 80s, the average weight of a putter head was under 300 grams. But if you looked at what's happened now they're up to like 360 grams.
And even higher.
Some are. So the question there was, well, why has that happened? And the answer has really been agronomy has changed. So green speeds, when you first heard a green speed was going to be 10 on the stimp meter, you probably hyperventilated. I know I did.
Yeah.
Now the tour players don't get scared until they're 15, right?
15.
So
Ouch.
because these greens are getting so much faster, they don't want to take big strokes. They just want to have, they don't want to have a lot of movement, right?
So that's why. So it's kind of counterintuitive. The faster the green,
heavier the head,
putter.
smaller the stroke, right? So they don't
Smaller
have
the
to take a
stroke.
big stroke and they control it better. And then, so that's happened. Swing weights have started to get heavier as this mass has gotten heavier. The shaft has stayed the exact same. Nothing's happened with that. And then in about 2012 or so, and I would say the inflection point was really more like 2015, super stroke grips, or these light, oversized grips, came into vogue, right? And a lot of people have really liked them. And what's happened is, because these grips are so light, a normal putter grip is 75, 85, maybe 90 grams. These all of a sudden are 50. So now you have a really heavy head, you have a really light grip, and swing
weight
weights
goes
went
through the roof.
up
Yeah.
to F3. I guess I would ask anybody watching this if they play an F3 in their driver, and my guess would be no, because it's too difficult to control. And what's happened, the reason why golfers have not gotten better is because their strokes are still bad or getting worse.
Yeah.
So when I say they're bad, that means they're inconsistent, and if it's inconsistent, they're unpredictable.
And so the heavier the weight, what we've found is way more difficult to get that transition smooth.
You hit it on the head,
You know.
and especially on longer putts. We see it on short putts too, but when you don't have a consistent, predictable transition on a longer putt, which is where most golfers get in trouble with 3 putts, you can't control your distance.
So let's describe what
Yep.
the move that you made
Okay.
for shafts.
Let's talk about this one. So this is a steel shaft.
Right.
And literally the steel shaft has been the same since 1975. So that's a long time ago, Leith. I was,
And you
what was
said-
I was a sophomore in high school, and we had more hair, and it was
You're a youngster.
yeah, right. So this was the same shaft, right? So if we'll just call this a tube. And if you think about what we used to hang on the end of this tube, it was 290 grams, and it was a ping
was ping,
zing
and-
or
and they won
ping
the
answer,
world with
right?
that,
They dominated. So a tube with 290 grams hanging on one side of it is going to react a certain way. Now we have the same tube, but we're hanging a putter head that weighs 360. The tube can't work the same way. So what's happened? It's gotten way too soft, and there's way more flutter in that, right? Which is difficult for a golfer to really control. And they're heavy. The 115 grams of weight in the middle, that doesn't do you anything. So what we learned from all the work we do on full sets of clubs is drivers and irons and things, is there's a measure of forgiveness called moment of inertia, right? Listeners would know that as MOI. So if we could improve the MOI of the head, that would be good. But we started to get curious, what if we could improve the MOI of the entire club?
Because you're realizing, just reminding everybody that these steel shafts had one overriding quality that every manufacturer was searching for,
Yeah.
and that was
They were inexpensive.
They were inexpensive.
Right. So that was good, but they were no longer suitable. So what was happening, the reason why golfers' putting strokes were inconsistent is because the way the putters had been balanced had changed so dramatically. From C8, C9, mid-Ds, up to F3. And it got to the point where a golfer couldn't control that anymore. So the heads just got way too heavy for the rest of the
So
system.
let's describe what we're doing now.
Okay, so like I said, a normal steel shaft will weigh about 115 grams. This is a new shaft that we developed with our friends at True Temper, which we now have the intellectual property for, that is about 2/3 graphite and about 1/3 steel.
Just to explain exactly what that means, intellectual property ownership means only Callaway has it.
Right, so this would be good. Warren Buffett calls it a moat, right?
moat, yeah.
So which is an important thing to have. So, but what's important about it is it only weighs 75 grams. So if I was going to make a head more forgiving for you, I would take weight out of the middle and I would put it to the edges, right? That makes it more difficult to twist or turn on a mishit, right? Something off the center. So the inertia goes up. So that's exactly what's happened here. The inertia has gone up. We've taken what already was a quite heavy head and actually made it a little bit heavier, which might be a little counterintuitive. I'll get to that. So the heads are 360 to 365 grams, but then we've taken a grip that typically weighs about 70 grams, and now our grip is going to weigh, or 50 if it was an old Super Stroke, right? And we've taken a grip that weighs 60 or 70
And
grams.
show the little counterweight.
And,
yeah.
and a little bullet that goes into the bottom here. And now the grip and the weight combination is 105 grams. So the overall weight of the putter is still 540 grams. It's just total rebalance. I wouldn't say it's counterbalanced, it's rebalanced. And what's happened is we've moved 23% of the weight now up closer to the hands, got it in way better harmony with the golfer. Biomechanics are way better. And this is the things that we've seen. Remember I said golfers have bad strokes? This improves the consistency of a golfer's putting stroke, the length of the backstroke and the transition that you talked about by 21%. The position of the club face off the ground.
Let's go through that.
By 20%.
Let's go through those testing details.
Yeah.
And, you know, because you made the change, redistributed the weight,
Yeah.
made that shaft a little stiffer,
Right.
which is another thing that we're finding is that with putter shafts, stiffer is better.
Yeah.
So then describe,
Especially with these heavier heads.
especially with the heavier heads. So
Right.
then describe what you did, what the testing has showed in terms of measurable improved performance.
Yeah, this is where we get really excited as club designers and club geeks, where we could tell a golfer 2 or 3%, right? I mean, that's a big
would be
number.
good.
We fight for that. 20% improvement in the length, consistency of the length of your backstroke.
20% improvement in the consistency of the length of the backswing.
21% in the height of the putter off the ground, which has a lot to do when it comes back to the golfer's ability to hit it in the middle,
Right.
which is controlling speed and distance and all of that.
Got to hit it in the middle.
18% more consistency in the face angle at the end of the backstroke, which means now the amount of work that you need to do as a golfer to get it back to square is way more predictable, way more consistent.
And so that has to do with like the increased moment of inertia.
So it's all of that has come into creating these incredible improvements. But then we see face angle at impact, which is really important, 13% better. That's where does it leave? Does it leave where you want it to leave? And speed, impact ratio, all of these things that have a lot to do with your ability to control distance, 15, 16, 18% better. So those are astounding numbers. Enough, Leith, that we went through then and changed every putter we make in our line this year. We'll have the Stroke Lab technology.
Which, of course, then the next question everybody always wants to know is, well, what's happening on tour with this putter shaft?
Yeah. So last week, there were 6 major tours in play. We had 83 Stroke Lab shafts in play. It's had 4 wins already as a prototype, and we just literally just launched it.
So how many weeks out is it?
That we've had it in the marketplace 2 weeks.
2
And our
weeks.
sales are
4 wins, 80 of these shafts in play on tour. So
Right.
the tour pros are going for this concept of
all around the world.
graphite, steel, put them together.
It's just better. It's a better way. I believe it's an inflection point, and I think it's one of those things where we'll look back, Leith, and say, remember when we used to play steel shafts in our driver? But I honestly think that's going to happen here. It's better. It's just better.
Well, that's great. So you feel like you're on top of the world right now?
I don't know. I'm sure we'll come up with more things that we can do to improve it, but right now we're super excited with what we have.
You don't want to say anything about what you've got still back in that two-line
No,
garage. Huh?
we're working on it.
Okay, well, Sean Toulon, Senior Vice President of Callaway, running the putter business for him here at the Indiana Golf Association show. And Leith Anderson from upstairs, the Indy Putting Lab upstairs at Correct to Compete, and thank you very, very much
You're
for
welcome, Leith.
doing this.
Yeah, enjoyed it very much. Nice to be
Great.
with you.